Hello, welcome back to the course, to the seminar Basic Python. This is session 11 on data analysis. And today we will be using pandas, which is a Python package for loading and working with tabular data. So the dataset that we'll be working with today comes from this study. This is a study from the Journal of Experimental Biology, and they were investigating the heart rates of emperor penguins, in German Kaiserpinguine, while these penguins were diving into the water. So this is just a screenshot from the paper, from the publication. And this is a look at the dataset. So the dataset is available from the GitHub repository that is underlying the course website. We already had a close look at this file, I think 2 sessions ago, when we were talking about how to read and write into files. And if I download this file and just open it in an editor, this is how it looks like. So it's just a text file, and it has this structure of a CSV file where CSV stands for comma separated values, in which we have a header line which tells us something about the column titles, and in which each row then is one observation and all the measurements are separated by commas. That's why it's called a CSV file. And pandas allows you to read such information into data frames. So in order to explain data frames, I'm now switching to Spider, and we'll start analyzing this data set. So first, I have here a Python script which loads this file as a plain text file and prints the first 6 lines from it. So if I run this, I get the following output. So this is just to reinforce the point that a CSV file is a plain text file. There's no other information in the file other than the text that you see when you open the file. So no formatting information like in Microsoft Word documents, for example. It's really just a plain text file. Still, you shouldn't read it in Python like a plain text file, because there are specialized ways for dealing with CSV files, and these are included in the pandas package. So before we continue, we're going to import pandas. Pandas is a third-party package, meaning it does not belong to the Python standard library, but it's a rather popular package and therefore included in distributions of Python like Anaconda. So if you have installed Anaconda, you should automatically also have pandas. Okay, and then from pandas, we can use the function read CSV, but before we have to define the file path. And then we can call pandas.readCSV. That's a function from this package, which takes as an input argument the file name of the file that we want to read from. And the result of this operation should be written into a variable called penguins. We will in a few minutes see what data type this variable belongs to. But for now, let's just print this output. And if we print it, we see this overview. So if you're trying to find out what this CSV file contains. It's a list of observations. There are 125 rows in the CSV file where each of them stands for a single observation. And for each observation, it has been recorded what the bird was. So that's supposedly the ID of the penguin, which was investigated. And then the duration, the depth of the dive of this penguin, as well as its heart rate during the dive, were also recorded. I think duration is in minutes, depth is in meters, and heart rate is in beats per minute. Okay, so this is the information contained in the CSV file penguins.csv. The file also exists as an Excel file. So if I double click on this in the Explorer, it brings me to Microsoft Excel, opening the file, and we see that it has the same contents. However, if we are opening this XLSX file in an editor, we see that it is not a plain text file. So there's a lot of control and formatting information contained. So reading it as a plain text file or as a CSV file wouldn't work. So for this, there is another function in Pandas, which is called read Excel. And it again takes a file path as an input. I'm sorry, I of course have to adapt the file path. And one more time. And if we print this, we see that it has the exact same contents as the CSV file. So before we go on with having a closer look at this penguins variable, I just want to make one short point, which is that Pandas also allows reading data from the internet. So this is the penguins file on the GitHub repository underlying the course website. And if I click here on raw, open this link in new tab, I get the URL of the file which contains only the file contents, only the plain text file, and not all the formatting and HTML as on this website. So we can, in principle, take this URL and store it as a string. And then once again, from pandas, call the function read CSV. But this time we don't take the file path as an input, but we're using the URL. So this succeeds. We don't get an error message very well. So this means that if your computer has an internet connection, you are allowed to also read files which are deposited somewhere on the internet, provided that they have the correct format, of course. Okay, now let's take a closer look at this penguins variable. First, let's ask what data type the variable penguins belongs to. So this is a pandas data frame. And a pandas data frame is something like a matrix in the sense that it is organized in rows and columns, but there's more structure to a data frame than there is to a matrix of numbers only. So one point in which a data frame goes beyond a matrix is that that the columns have titles. So each column is given a title more closely describing the measurement that it contains. This is semantic information. The second observation that we make is that the data frame appears to allow non-numeric values. So here in the bird column, we have penguin IDs, and these are obviously not numbers, but strings. So other than in a matrix or a NumPy array, we are allowed to say non-numerical values in a data frame. So the rows of the data frame are typically referred to as observations, and the columns are typically referred to as measurements. Note that here the observations are not single penguins, but the observations are single dives. Yeah? So you see that the entries in the bird column are repeating, meaning that always a couple of dives were recorded from each penguin. Okay, so next topic is indexing. What if we want to extract specific information from this data frame? How can we do this? So we can get individual columns from the data frame by just indexing it and using a string indicating the title of the column as the index. So with this, I get a new data frame which contains all the information in penguins, but only from the column Z. And this is then being printed. So in this way, we get only the contents from the depth column. We can also ask what type of data this column contains by indexing the column and then writing dot dtype. And this tells us that this column is of the data type float64. And for all our purposes, float64 will be like Python's float data type. If you're wondering what data type the bird column is, it definitely cannot be float or int, because it has non-numerical values. This is the data type O. So the O stands for object, and in Pandas, object is a generic data type used for anything that is non-numerical. So, and in the case that we are reading plain text files, these will be most often strings. Yeah? So consider O being the data type used for identifiers and string information describing categories rather than numerical values. Okay, we cannot just index a single column, but we can also index multiple columns. So if I go back to this command and now add duration as the second column I want to have a look at, I can index this in this way. Please note the double use of square brackets here. The first pair of square brackets is for signaling that I want to index this data frame. And the second pair of data frames is for creating a list. Yeah. So If I want to index multiple columns, I have to provide the indices as a list of strings or of column titles. And with the inner pair of brackets, I'm creating this list. So if I enter this command, I get the two columns from the data frame printed to the console. So if you are ever wondering about the names of the columns of a data frame, you can get a list of them by just accessing the attribute columns of a data frame. So this means that if you type print penguins and you are indexing using the list of all columns, this gives you the entire data frame again. Otherwise, always provide the list of columns that you want to extract as a list of strings. Okay, so we can, in this way, we can index columns. The question is, can we also index rows? Yes, we can. And the way for indexing rows is just equivalent to indexing multiple entries in lists or tuples or strings, for example, meaning that we simply create a slice anything containing such a colon marker here. And as we know, this slice gives us everything from the fifth entry up to, but not including entry 15. And remember that this is Python-based counting, which starts at 0, meaning that the first line that we will get is the sixth line, which is, however, called in Python pandas line 5. So if we hit enter on this one, we get this subselection of the data frame. So one unfortunate property of Python is that we cannot use this notation to index single rows. So if, for example, I ask Python to give me the fifth row, which is row 6, from the data frame, I get an error. So before I explain where this error comes from, one way around this is to just provide a slice, which ends up giving you a single line, and then you will be able to access a single line. So this is slice indicating start from entry 5 up to but not including entry 6, and this of course will only be entry 5. Okay, so now the explanation where this error comes from. The reason is that we were using the same notation for indexing columns and rows. We were always using those square brackets. Except that, of course, we were putting different strings into the square brackets, either column titles or row numbers. Now, if we use the same notation for indexing columns and rows, pandas needs some way of deciding whether we, in this particular moment, want to index column or rows. And pandas does the following. When you provide a slice as an input, then pandas assumes that you want to access multiple rows. So it interprets this slice as belonging to multiple rows. When you input anything that is non-slice, pandas assumes columns and gives you the associated columns. And this is because, and this is the reason why if we just enter penguins 5, that pandas does not recognize this as referring to the fifth row. Instead, it is searching for a column whose title is 5. And there doesn't exist such a column, and therefore we get an error from this command. So there is a way of indexing single rows without slice, and this is pretty complicated, so I'm trying to explain it now. Data frames have two methods called log and ilog. So log stands for location and ilog stands for integer location. So the integer location method allows you to extract single rows by just giving the index of this row. So in this way, we get the we get row number 5 as an output without having to provide a slice. So remember that this is Python-based counting, so this is the 6th row. The integer location method also works for accessing single cells, not just single columns or single rows, but single cells. So if, for example, we want to see the third column in the 6th row of the data frame, we can enter ilog 52. And this will give us the depth. This is the third column. From the 5th row. So this value should be equivalent to this one. Now, this is ilog for integer location. We can also use log to achieve the same thing. So if we, for example, replace the 2 by depth, we get the same number. Again, the 32.5. The log also allows you to access multiple columns by, again, providing a list of column titles. Then you get 2 entries instead of just 1. And you may start to think now that the only way that log and ilog are differing is in the way of addressing columns, because the call ilog52 is equivalent to the call log5 depth. And this suggests that the only way in which they're differing is how they access columns, but the rows are the same for both. This is not exactly true. And to explain this, let me create a subset of the Penguins data frame, which contains all the rows from 5 to 15. Let's have a closer look at this. Okay, so note that in this new data frame, Penguins subset, the row counting does not start at 0, it starts at 5. Yeah? This is because when we were accessing the subset from this data frame and wrote it into the new variable, Pandas has taken the row numbers from the original data frame into the new data frame. Even though the new data frame doesn't have 14 rows, it has a row called 14. So this means that if we are now indexing Penguin's subset using ilog, which uses the actual numbers of the rows, so the actual index, we get the 5th row, which is row number 10, this one. In contrast to that, if we index penguin subset using the log method, we do not get the fifth row from this subset, but we get the row actually called 5. Yeah, so this one. Therefore, log and ilog may refer to different rows if the row numbering does not start at 0, which, for example, happens if you have formed a subset of a data frame from an earlier data frame. So to sum this up, ilog uses actual row and column numbers, so pure indices for indexing, whereas log uses labels of rows and columns for indexing individual cells. Okay, so this was it for Python indexing, and I know this can be confusing, but although you will probably very rarely use log and ilog because rows and columns are not distinct by their position in the data frame, but they are distinct by the values that they contain. So the values give the entries in the data frame meaning and not the position. Oftentimes, we are, instead of accessing entries in the data frame via their position, accessing them by asking whether they fulfill a certain condition. And this will be next topic, namely Boolean indexing. So the rows in a data frame are often arranged in arbitrary order if you don't have time series data. Unless, of course, you have time series data. In this case, the order is not arbitrary. But in this case, for example, we could like shuffle all the rows of the data frame and the data set would still be the same. It would still contain the same information about individual dives from individual penguins. And therefore, the meaning of the data in this data frame does not come from the position of the entries, but from their values. And this is used when selecting entries from a data frame based on logical statements. So we can, for example, access the column depth in the penguins data frame and threshold this at 150. So this is a logical statement, which can be true or false for each entry in the depth column. Which is why if we execute this statement, we get a new data frame whose data type is Boolean, meaning that each entry in this data frame is just a true or false value depending on whether the entry in the penguins data frame fulfills this statement. Now, this is great because just like last time when we were looking at array computing, those logical data frames can be used for indexing the data frame. So if I take the same logical statement from before and enter it as an index into the penguins data frame, I get only those entries of the data frame which are fulfilling this condition. Those logical statements can, of course, combined with additional operators. So we have the AND sign, which stands for logical AND. We have the pipe operator, which is alt gr, and then the key next to your shift, at least on my keyboard. This is logical or. Logical and means that both statements need to be fulfilled. Logical or means that one of the statements need to be fulfilled. At least one. And then we have the tilde symbol, which stands for logical not. So if you want the opposite of some condition to be fulfilled, often for this you can of course also use exclamation mark equal if the logical condition that you want to check is a check for equality. Okay, let's just have a look at one example for this. So we take the last query and add another condition. So we ask whether the depth of the dive is larger than 50 and the duration of the dive is smaller than 5. So this will supposedly give us dives which are rather deep but rather short. If we are combining statements, these should be included into round parentheses. And then take a close look to ensure that you're closing all the brackets correctly. And then asking for this condition only gives us 2 entries from the data frame. So only these 2 entries were deeper than 50 meters and shorter than 5 minutes. Okay, so before analyzing a set of data, one often wants to have an initial look at the data and explore the distribution of all the measurements in the data set. For example, one would want to know what the minimum in this column is, what the maximum in this column is, what the mean value is, and maybe what the standard deviation is. So this process is called aggregating. So aggregating means to provide summaries or summary statistics for measurements in a data frame. And often these summaries are provided by aggregating multiple values from a column in a single number. Before we start with this, I want you to import the statistics module from the standard library as stats. So this will make things a bit easier. Okay, so now the general syntax of the aggregate method is as follows. You take a data frame. So here DF is supposed to stand for generic data frame. Write .agg, this stands for aggregate, and the input argument to this function is a list of functions that you want to calculate for this data frame. So let's try to do this for our data frame. We will define a list called summary stats. And this list will look as follows. It will contain min, stats, median, stats, mean, stats, stdef, which stands for standard deviation, and max. So in this list, I'm simply collecting a few functions. Min and max are built-in functions, and the other ones are available from the statistics module. So this gives us the median, which is exactly the middle value when sorting the data. This is the mean of all the values, and this is the standard deviation, which is a measure of dispersion. Note that I'm not calling these functions here. There are no like brackets or parentheses, which I'm using, and then input argument. I'm just listing those functions and store them in a list. So now I can apply the aggregate command and write down the name of my data frame .agg and then in brackets summary stats. I could have equally well put this entire list here into the parentheses as an input argument, but I've already stored this list under a variable name. So I'm going to go with this command. Now, the result from this is a new data frame in which the columns are exactly identical to the columns of the data frame from which you were aggregating. And the rows correspond to the functions that you have listed as an input to the aggregate method. So we get these summary statistics calculated for each column in the data frame. You can see that this also results in questionable output. So, for example, we also get a min, median, and max for the bird column, the penguin IDs. And the reason for this is that Python or Pandas uses sorting for determining the minimum, maximum, and median, and there, of course, exists rules that determine how strings should be sorted. However, then there are values which to calculate is not possible, which are these two, and these are then designated as NaN. NaN stands for not a number. So those who are working with MATLAB should be familiar with this terminology. Okay, aggregate can also be used with a dictionary as input. So if I don't want this output for other columns, because you can see that for some columns it doesn't make sense, I can also define a dictionary and in this way enforce that the summary is only calculated for some columns. So a dictionary consists of key value pairs, and here the keys must correspond to the column titles and the values must correspond to the summary statistic that you want to calculate. At which position we are again referring to the list that we have created further up. So if I now aggregate again, but using the summary dictionary as an input argument, I only get this output for the depth and duration columns, which is a bit more appropriate because, as we have seen, those summary statistics don't make sense for the bird column. In this way, you can also vary the summary statistics by column. So, for example, we can allow to calculate the entire summary statistics for the heart rate column, while for the depth and duration column, we only want to see minimum and maximum. And if we print the aggregate command with this dictionary as an input, we get everything for the heart rate and only minimum and maximum for the depth and duration column as we have specified it. Okay, so now what about the bird column? Can we at least do some statistics for the bird columns? Yes, we can. And for that, we need the method value counts. So first access the column bird in the data frame, and then write dot value count. So we are applying the method value count. And this then gives us a new data frame in which the number of occurrences of each individual IDs in the bird column have been counted. So this is a summary which is appropriate for an ordinal or nominal data type, um, which we don't have explicit numerical information, which can be used for calculating mean and standard deviation. One can also use the keyword argument normalize of the value counts function and set it to true, in which case we will get relative frequencies. So here we got absolute frequencies, so actual numbers of occurrences, and here we get relative frequencies, which are just the number of occurrences divided by the total number of observations. Okay, so the last topic that we want to have a look at today is grouping. So here's the general syntax of the group by method. Take a data frame, the df once again is a generic data frame, and then write dot group by, and the input argument to the group by function should be a list of columns by which you want to group the data set. So if you're running a study which investigates males and females and smokers and non-smokers, you can group by two variables. You can either group by gender, which gives you males and females, or you can group by smoking status, which gives you smokers and non-smokers. Or you can also group by both variables, in which case you will get four groups: male smokers, male non-smokers, female smokers, female non-smokers. So here, in this data set, we have just one variable which allows to group by, and this is the penguin ID, so the column bird. If we now apply the group by method to the penguin data frame and provide one column name, this by itself doesn't do anything. This just gives us a grouped by data frame. So this is just the same data frame, but with the virtual information added that all the observations having the same penguin ID should be taken together or should be viewed together. So we have not done anything with the dataset. We have just grouped it into two categories based on the bird color. Now, the group by method is most powerful in combination with the aggregate method. So what we can do now, for example, is to take this grouped by data frame, call the aggregate method, and calculate the minimum and maximum. So we already know what happens if we apply this to the data frame alone. We get minimum, maximum for each column. Now, what happens if we apply this to a grouped by data frame? Well, now we get this information for each individual group. And in our case, the group is a group of dives which are all belonging to the same penguin. So we get minimum and maximum for all columns in the dataset separated by penguin ID. And we, of course, don't get these values for the bird column itself because the bird column was already used for grouping the dataset. And so it wouldn't make sense to calculate minimum maximum because the values are the same in each group. Okay, great. So this was it for today. One thing I should maybe say at the end is that there are no homeworks. And instead, I want you to read the statistical models section from the data analysis chapter on the course website. This will become important for next week's homework. So the section that we were looking at today is a pretty long section, and we were covering the data analysis part today up to this point, up to data visualization, which will be the topic of next week. And as a homework, I want you to read the third section from this chapter, which is called statistical models. This is not so much about programming, but is more focused on statistical models and what they mean. And please read this section because this will then enable you to do the exercise at the very end of the data analysis chapter on the website. Okay, with that, I want to say thank you. This was the data analysis session. So goodbye, and I hope you also enjoy the other videos. Bye bye.